The machine is running, that much you can hear. Fans, disk, a cursor blinking in a dark terminal as if it already knows something you do not. Somewhere behind that prompt sits a cluster, machines pretending to be one computer and software pretending to be immortal. If you cannot see what is actually alive in there, you cannot tell whether the application exists, whether its pods exist, or whether anyone can reach it at all. Visibility and control pull in opposite directions. Listing things does not change them. Changing things without a record leaves you guessing later. This is the tension an operator lives inside. The cluster will not narrate itself. It answers only when asked, in the terse dialect of kubectl. One mistyped name, one missing replica, one service that never found its pods, and the whole system looks healthy from the hallway while remaining empty on the inside. Tonight we follow that prompt from uncertainty to intervention, not as a catalog of flags, but as a story of how a hidden machine becomes accountable. The first question is almost insultingly simple. What is actually running? Before a single command is useful, the geography has to exist in your head. A cluster is not a blob. It is a nested map. At the outer edge sits the cluster itself, the political boundary of everything you are allowed to manage. Inside it, nodes, real or virtual machines that actually have CPU, memory, and a network card. On those nodes live pods. A pod is the smallest deployable unit, a little envelope that can hold one container or several that must share a network namespace and a fate. Inside the pod, containers. That is where the process actually runs, where Nginx listens, where logs are born. Watch the chain. Cluster, then node, then pod, then container. If you skip a layer, diagnosis becomes superstition. You will blame a node for a container crash or blame an image for a scheduling problem. There is a second map, equally important, that does not sit in hardware. A deployment does not run your code. It declares how many copies should exist and then keeps creating pods until reality matches desire. A service does not contain your code either. It is a stable name and a set of endpoints, a door that should lead to whatever pods currently wear the right label. Deployment to pods, service to a reachable application. Those two arrows are how an operator thinks when the terminal is quiet and the pager is not. The first honest act is not creation, it is reading. kubectl get followed by a resource type is a read operation. Nodes, deployments, services, config maps, whatever you name, the cluster answers with a table, or with almost nothing. The wide lens is kubectl get all. It tries to show the cluster's working set in one glance. In one real terminal, the command returns a single lonely row, a service named Kubernetes, type cluster IP, address 10.96.0.1, no external IP, port 443 over TCP, age 10 days. That is the control plane talking to itself. No application pods, no user services. The machine is running and the inventory is almost empty. That emptiness is information. Get all is not a health check, it is a census. It will not tell you why a pod is pending. It will not tell you that a label drifted, but it will stop you from inventing a workload that is not there. Operators who skip this step create second copies of things that already exist, or they debug ghosts. The table columns matter too. Name, type, cluster IP, external IP, ports, age. Those headings are a first map of identity, reachability, and time. If the census is blank except for the cluster's own service, the next question writes itself. Can a command make something real? Get all is a panorama. Sometimes you need a window. kubectl get nodes asks the cluster which machines it believes are members and whether they are ready. If a node is not ready, every later mystery about pending pods may already be solved. kubectl get pods asks a narrower question. Which envelopes exist, in which phase, on which node? Restarting how often? A crash loop backoff in that table is a confession. A pending row is a shrug. The scheduler has not found a home. kubectl get services asks who is advertised. A cluster IP that never acquired endpoints is a door to nowhere. These three commands are the same verb with three nouns, and the nouns change the story. Nodes are capacity, pods are life, services are how life is found. The reference also offers kubectl get resources as a generic form, a reminder that Kubernetes is not only these three kinds of object. Deployments, replica sets, config maps, secrets, volume claims, each can be listed the same way. The operator's discipline is to choose the smallest truthful window. Too wide and the signal drowns. Too narrow and you miss the node that is dying while you stare at a single pod. Seeing resources is still not the same as knowing why they behave. The tables are shadows on a wall. Something has to cast them. Creation is irreversible in the only way that matters. It changes the world other people are watching. So the reference begins not with a live apply, but with a rehearsal. kubectl create, then dry run, then validate, then -f, then a file named pod-gfg.yaml. Nothing is born. The API server is asked to pretend and to complain if the document is illegal. That is the first pact between visibility and control. You may act, but you should first hear the cluster refuse you. Dry run is not cowardice. It is a way to keep the desired state in a file while still using the create verb's strictness. Validate catches the boring disasters, a missing required field, a typo in a kind, an image name that never even reaches a node because the object was never admitted. The file name in the example is specific. The habit is general. Keep the YAML, point the command at the file, ask the cluster to rehearse. Only then spend the real mutation. There is a cost. Dry run will not tell you that the node has no capacity. It will not tell you that a secret is missing at runtime. It only certifies that the document is a legal intention. Intention is not health. But without a legal intention, every later log line is noise about an object that should never have existed. The rehearsal ends. The operator still has not created a workload. The cluster is still mostly empty. The next temptation is to skip maps and files entirely and just ask, how hot is the metal? A census of names is not a census of load. kubectl top node asks how much CPU and memory each machine is actually burning. kubectl top pod does the same for envelopes. Narrower still, kubectl top, a pod name, and the containers flag, so you can see which process inside a multi-container pod is the glutton. Widest of all, top pod across every namespace, with containers set to true, a full accounting of every running process the metrics pipeline can see. These commands do not create capacity. They only reveal the argument between desire and physics. A deployment that wants 3 replicas on a node that is already at the memory cliff will look like a software problem until top shows the cliff. The catch is quiet and important. Top depends on metrics existing. If the metrics path is absent, the command fails, and that failure is itself a kind of visibility. You cannot manage what you cannot measure. Performance is the chapter where visibility almost becomes control. You still have not scaled anything. You have only learned whether the metal can take another replica. The numbers tempt you to act immediately. Scale now. Evict now. The reference will not let you skip the social layer first. Workloads are not found by IP address alone. They are found by labels. And labels, unlike CPU, can lie if a human typed them. A service does not know your pod's name. It knows a selector. Labels are those little key value tattoos. Owner equals GFG, app equals NGNX, kubectl get pods -l owner equals GFG is not sorting for beauty. It is asking the same question a service asks, who belongs to this set? Adding a label by hand is a one-line act. kubectl label pods, the pod name, owner equals GFG. Removing it is almost the same line with a minus after the key. In the reference, the removal looks slightly bruised, owner dash, then a stray token. The idea is still sharp. Labels are cheap to attach and expensive to get wrong. Annotate this in your head as a social contract. Deployments stamp labels onto the pods they create. Services select those labels. If you hand edit a live pod's tattoos, you can orphan it from its service or kidnap it into the wrong one. Visibility here is a filtered table. Control is a tattoo gun. The two can fight. An operator who only uses get pods without the label flag will see a crowd and assume they are a team. An operator who only labels and never lists will not notice the pod that never received the stamp. The cluster does not care about your intention. It cares about equality of strings. After labels, the reference turns to something that must never appear in a table casually: secrets. Names you can list, values you should treat as radioactive. kubectl get secrets with all namespaces is a roll call of hidden objects. Certificates, tokens. The kube config shaped secret in the example is named gfg-cluster-kubeconfig. The second command fetches that named secret. The source even misspeaks in the heading, calling it a hidden field of a secret, which is a useful slip. Listing names is not the same as printing every value on a shared screen. Secrets are where visibility becomes a moral problem. An operator who cannot list them cannot debug a pod that cannot pull an image or speak to a database. An operator who dumps them into a ticket has enlarged the blast radius. The cluster stores these objects as first-class resources, which means they appear in get, describe, and apply workflows, just like a deployment. That is the point and the danger. They are ordinary to the API and extraordinary to people. Notice the namespace flag. Secrets hide in corners. Default is not the only room. A cluster that looks empty in one namespace can be crowded with credentials in another. After this, the story returns to the public face of the system. If secrets are what the app knows privately, services are how the world is supposed to find it. A service without endpoints is a polite lie. The next commands ask whether the door is attached to anything alive. kubectl get services lists the advertised doors. kubectl get endpoints lists who actually stands behind them. That second table is the one operators forget, and it is the one that tells the truth. A service can exist, look ready in conversation, and still have an empty endpoint list because no pod matched the selector. kubectl get service, a name, -o YAML, dumps the whole contract, ports, selectors, type, session affinity, the desired story in a document you can read slowly. Storage has its own census. kubectl get storage class lists the kinds of disk the cluster knows how to mint. Checking a mounted volume in the reference is framed as an exec into storage. Checking whether a volume persists is a describe on the persistent volume name. The commands are slightly rough in the source. The idea is not. Compute without storage is amnesia. A pod can be replaced. A claim is how you ask that the data survive the replacement. Service plus volume is the moment the map grows a third axis. Not only where code runs, but how it is reached and what it remembers. Apply will soon treat all of this as files. Before that leap, remember the pairing. Get services for the door, get endpoints for the room behind the door. If those two disagree, do not scale yet. Do not restart yet. You have found the lie. The next chapter is about refusing to keep the truth only in your head. Imperative commands are fast and forgetful. You type create, the cluster obeys, and the intended shape lives in your scrollback, which is to say it lives nowhere. kubectl apply is the counterspell. With apply, resources can be created and modified from a configuration file, or from a whole directory of configurations. The basic syntax is almost humble. kubectl apply-f, then a file name ending in YAML. That -f is the whole philosophy. The file is the desired world. The cluster is asked to move toward it. If the object does not exist, apply creates it. If it exists and differs, apply updates it. The operator stops being a person who issued a one-time wish and becomes a person who keeps a document. Visibility and control briefly shake hands. You can read the file, you can version the file, you can dry run the file, you can apply the file again tomorrow and get the same shape, not a slightly different one born from memory. There is still a hook. A file can be wrong with great confidence. Apply will faithfully install a bad selector, a bad image, a service that points at a label no pod wears. Repeatability is not correctness. It is only the ability to be wrong the same way twice, and therefore the ability to notice and repair. The census taught us the cluster was empty. Apply is how emptiness becomes a declared workload instead of a lucky accident. Sometimes you do not have a file yet. You have a name and an image and a number. The reference shows the imperative path. kubectl create deployment ngnx dep -- image equals ngnx. The cluster answers in one green line. Deployment.apps ngnx dep created. That sentence is smaller than what it did. A deployment object now exists. It will create a replica set. The replica set will create pods. The pods will pull the ngnx image and try to become ready. The name is not decoration. ngnx dep is the handle every later edit, describe, and delete will use. Watch the map light up. Deployment to pods. The deployment does not listen on port 80. The container inside a pod does. If you stop here, you have life without a door. That is a common halfway state. Get pods shows running, get services shows nothing you created, and someone on another machine cannot reach the page. Imperative create is honest about speed and dishonest about memory. Tomorrow you will not remember whether you asked for one replica or two. The scrollback will be gone. The object will remain. This is why the story cannot end at created. A second command has to expose the thing, or the workload is a tree falling in an empty forest. The companion line is almost casual. kubectl create service node port ngnx -- tcp equals 80:80. The reply, service/ngnx created. A node port service is a door on every node, mapping a cluster port to the container's port 80. The name here is ngnx, not ngnx-dep. That mismatch is not a typo in the documentary. It is a warning baked into the example. Create can succeed and still fail to connect the story if labels and names do not agree. On the map, draw the second arrow, service to a reachable application. Endpoints should populate with pod IPs once selectors match. If they do not, you have two healthy-looking objects and no path between them. Node port is a particular kind of reachability, not only a cluster IP inside the cluster, but a port on the machines themselves. That is useful in a lab and noisy in a lockdown network. The reference does not argue policy, it shows the verb. Create deployment, create service, two mutations, two names, one intended user journey. The hook from the opening returns. Seeing resources is not knowing why they behave. You can now see ngnx-dep and ngnx in a get all that is no longer empty. The next urge is to tinker live. Open the object, change a field, hope the cluster follows. That is edit. It is powerful and it leaves fingerprints only on the live object. kubectl edit, then a resource type, then a resource name. The cluster fetches the live object, opens a Vim-like editor in the terminal, and waits. Save a real change, and the resource updates. In the captured terminals, both attempts end the same way. kubectl edit deployment ngnx-depl. Edit canceled, no changes made. kubectl edit service ngnx. Edit canceled, no changes made. That canceled line is more educational than a successful edit. It proves the loop. You are about to mutate live state with no file on disk to remember the new truth. Closing without writing is the operator choosing visibility over a hasty control. When an edit does land, it can change replica counts, images, ports, selectors. The deployment named in the pros as ngnx-deal is the same ngnx-depl from create, a human slip that live objects do not forgive. Type the name wrong and you edit nothing, or worse, you edit a different object. Edit is the rival of apply. Apply says the file is source. Edit says the cluster is source, at least for a minute. Teams that live only in edit become archaeologists of live YAML. Teams that forbid edit entirely sometimes cannot fix a burning production selector. The reference simply shows the door and the canceled exit. Deletion is the darker twin of the same grammar. kubectl delete resource type, resource name, or instead of a name, the all flag, which is a wide blade. The examples are specific and therefore safer to watch. kubectl delete deployment ngnx-dep. The cluster replies, deployment.apps, ngnx-dep, deleted. kubectl delete service ngnx, service, ngnx, deleted. Listen to what disappeared. Deleting the deployment asks the controllers to tear down the replica set and the pods. The process inside nginx is not asked politely. It is scheduled out of existence. Deleting the service removes the door. If you delete the service first, the pods keep running, unreachable. If you delete the deployment first, the service remains as a door to an empty room. Order is a kind of ethics. The all flag is mentioned because it exists, not because it should be a habit. It will remove every object of that type in scope. Visibility should precede that kind of control. Get, then delete the one name you mean. The census that was empty at the beginning can become empty again in 2 lines. That is the horror and the relief of a well-instrumented cluster. Nothing is mystical. Everything is named. Everything named can be removed. The next chapter refuses to live in one-off verbs. The same create and destroy, but the name lives in a file. The terminal in the example sits in a directory of YAML. kubectl apply-f nginx-service.yaml. The cluster answers service/nginx-service created. Later, the inverse. kubectl delete-f nginx-service.yaml. Service, nginx-service, deleted. Same file, opposite verbs. That pairing is the heart of configuration file CRUD. Apply creates if missing and updates if present, according to what the YAML claims. Delete-f removes the resource that file describes. You no longer have to remember whether the live name was nginx or nginx-service. The document remembers. The path in the prompt even tells a small human story. A folder called YAML, a file named for the object. This is slower than create service node port in one breath, and that slowness is the feature. A reviewer can read the file. A future you can reapply it after a disaster. The hook from earlier tightens. The resource exists because a document said so, but a created service is not a healthy application. You still need evidence from inside the envelope. The cluster can be perfectly reconciled and the process can still be screaming. Logs are how the container is allowed to speak without you stepping inside. kubectl logs, then a pod name. In the capture, the name is long and honest. nginx-76D6C9B8C-ZRBT9. That suffix is the replica set's fingerprint plus a random tail. The output is not a health badge, it is a diary. Docker entry point scripts fire, a listen on IPv6 helper runs, worker processes are tuned, then the notices land with a timestamp. 2022, November 15, 1826-38, using the EPOL event method. nginx 1.23.2, built by GCC, OS Linux 5.15. Those lines are sensory detail from inside a machine you cannot sit beside. You hear the server choose an event loop. You hear the version that actually booted, which may not be the version you believed you deployed. Logs are visibility without control. You do not change the process by reading it. You only learn whether it finished starting, whether it is still complaining, whether the last request 500 lives here or in some other pod. The command shows logs since the pod started, as the reference says. Restart the pod and the old diary can vanish. That is the hook. Symptoms without structure. You may need to step through the door, not as a tourist, as someone who can type inside the running container. That is exec. kubectl exec-it, the pod name, 2 dashes, then bash. The reference also writes bin/bash in the pros, and the screenshot uses bash. Either way, the meaning is, give me an interactive terminal inside that envelope. The prompt that returns is the tell. Root at nginx-76D6C9B8C-ZRBT9, a hash, a slash. You are no longer asking the API. You are a process among processes. This is control at its most intimate and its most dangerous. You can read files the logs never printed. You can curl localhost. You can also delete the wrong directory and call it debugging. The documentary tension returns. Logs were the container speaking. Exec is you speaking back. The cluster's controllers do not love this. Anything you change inside a container can vanish when the pod is replaced. That is why exec is diagnosis, not architecture. You enter, you learn, you leave. The prompt is a borrowed room. The hook is still waiting. Even a shell will not show you the deployment's desired replica count, its rolling update strategy, or why the controller thinks the object is available. For that, you do not enter the container. You describe the resource as the API sees it. kubectl describe resource type resource name. The capture runs it against deployment nginx. Name nginx namespace default. Created on Tuesday, 15 November 2022. Labels app equals nginx. A selector, the same. Replicas written as a sentence, 1 desired, 1 updated, 1 total, 1 available, 0 unavailable. Strategy, rolling update. Min ready seconds, 0. Rolling update allows 25% max unavailable, 25% max surge. Under the pod template, a container named nginx, image nginx, ports none in this dump, environment none, mounts none. Then conditions, the cluster's own verdicts. This is the structure logs could not give you. Desired versus available, image versus the version string you saw in the diary, selector versus the tattoos on live pods. Describe is where visibility becomes explanation. If desired is 1 and available is 0, you do not need a shell yet. You need events, image pulls, scheduling. If the image field is not the image you meant, every beautiful log line is from the wrong world. The hook from the beginning is almost answered. You can see, create, edit, delete, apply, listen, enter, and now explain. One fear remains. What if the explanation is that yesterday's change was the mistake? Can the change be reversed? Seeing the configuration is one kind of knowing. Moving a file is another. The cluster is not a sealed box. An operator still has to get a configuration into a container or pull a dump back out to the laptop that issued the command. The tool for that crossing is kubectl cp. Write it as kubectl cp, then the pod name, a colon, a path inside the container, then a path on the host. Reverse the 2 sides and the copy runs the other way. Host to container, container to host. Same verb, opposite gravity. The image must contain tar. That is not a footnote. The copy is not a special Kubernetes protocol. It rides on an archive created inside the container. If tar is missing, the transfer fails, and the failure looks like a cluster problem when it is really a missing utility in the image. So the operator who chooses a slim image later discovers that slim has a cost. Diagnosis, a script, a certificate, a captured log file, those objects still have to move. The map is simple. A pod name, a container path, a local path. The stakes are not. A wrong path overwrites the wrong file. A successful copy is quiet. It does not rewrite the deployment. It does not change the replica count. It only moves bits across the boundary that visibility and control have been arguing over since the first empty get-all. That is why this command sits late in the story. First, you had to know which pod was real. Then you had to be willing to touch it. Every change that lands can become the next outage. That is the last tension the reference will not let go. A deployment does not only create pods, it creates a replica set, and that replica set is the generation you can name later. kubectl get rs lists those generations. Without that list, undo is a wish. With it, history has handles. The rollout family is 4 verbs that treat change as something inspectable. kubectl rollout history shows what versions were applied. kubectl rollout undo walks 1 step back when the new image is worse than the old one. kubectl rollout status waits in the open, refusing to pretend the update is done until the cluster agrees. kubectl rollout restart does not invent a new application. It recycles the running pods so they pick up a fresh start without rewriting the whole object by hand. This is control with a memory. Create was fast. Edit was intimate. Apply was repeatable. Rollout is accountable. The operator who scaled, labeled, and exposed nginx dep can now ask whether the last change is still the one they want. If it is not, undo is a command, not a reconstruction from chat logs. Status is the antidote to hope. Restart is the admission that sometimes the specification is fine and the process is not. Together they answer the fear that opened this story, that a living system would become unrecoverable the moment someone typed. Recoverable is not the same as simple. It is the difference between a cluster you operate and a cluster that operates you. The prompt is still a dark rectangle. The difference is what an operator can now do with it. At the beginning, get all returned a single service and a question. Is anything actually running? Now the same verb can open nodes, pods, services, endpoints, secrets, and storage. Create can make nginx-depl and a node port named nginx. Apply can recreate nginx-service from a file and delete it the same way. Logs can quote nginx 1.23.2 from inside a pod named like nginx 76D6C9B8C-ZRBT9. Exec can drop a root shell into that same name. Describe can show one replica desired, one available, 25% surge, 25% unavailable. Copy can move a file if tar is there. Rollout can remember wait, undo, and restart. Visibility without control was a museum. Control without visibility was a dare. The commands sit on both sides of that argument, and they only work as a sequence. You look, then you declare, then you prove, then you keep a way back. What the field is still chasing is not another flag. It is whether a system this layered stays understandable as the number of resources and the number of changes both keep growing. The cluster will not get quieter. The question is whether the operator's map can stay as clear as the first line they typed.